Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4 and our group member is Ardini Damia, Nury Aryna, Afiqah Izzati and Nurul Balqish. The first part in this video, which is Chapter 2, Triple Integrals in Spherical Coordinates, will be presented by me, Ardini Damia and Nury Aryna. The question is, in a unit sphere, suppose the temperature at x, y, z is T equal to 1 plus x square plus y square plus z square. First, sketch the unit sphere centered at the origin and determine the limit in spherical coordinates. Then, find the average temperature by using spherical coordinates.
First, sketch your solid J. Our solid is in the form of a sphere, so we need to sketch it in three-dimensional. Let's look at our video on how to sketch our solid J. Okay, the parametric equation for a unit sphere is equal to x square plus y square plus z square is equal to 1. So our limit in x, y and z axis is equal to 1, 1 and 1 respectively. Okay, number 2, determine the limit in spherical coordinate. Step 1, find your integral. Since our question needs us to find the average temperature, we cannot use the equation that has been given in the question previously. Our average temperature is equal to temperature at each point over volume over sphere, which is 1 plus x square plus y square plus z square over 4 over 3 pi. And we can simplify this equation into this form. Step 2, find your limit. This is our general equation. To find the two uttermost limit, we need to look at our region. But what is our region? Let's take a look. So, our region is in the form of a circle. dv here is dz dy dx or dz dx dy. But here we are using the type 1. So, our dv is equal to dz dy dx. And our integral will be in this form. Since our region R is in the form of a circle, it is advisable to use spherical coordinate. Okay. We need to change x, y, z terms into the rho, phi, and theta. And our integral will be in this form, which is x square plus y square plus z square is equal to rho square, and our dv is equal to rho square sin phi d rho d phi d theta. Our limit for rho is from 0 to 1, which is from the origin to the upper surface of our sphere, and 0 to pi for the phi, which is angle in the z and y axis, and 0 to 2 pi for theta, which is angle in x and y axis.
After we find the limit in spherical coordinates, we need to evaluate the triple integral by using spherical coordinates. So, this is the equation that we get. We need to expand rho square sin phi into 1 plus rho square, and we will get this equation. After that, we need to integrate the equation with the most inner limit integrals d rho from 0 to 1, and we will get this equation. After that, we need to integrate for d phi from 0 to 5 into the equation, and we will get negative 8 over 15 cos phi. And then we need to substitute the limit value for d phi from 0 to 5 into the equation, and we will get 16 over 15. And the last one, we need to integrate the last integral for d theta from 0 to 2 pi into the equation, and we will get 32 over 15 pi minus 0. And the last answer will be 1.6. So, the average temperature is 1.6 degrees Celsius. The next chapter, which is chapter 3, will be presented by Afiqah Izzati and Nurul Balqish.
Moving to a second part, which is chapter 3, line integral and vector field. That will be presented by me, Nurul Balqish, and my group mate, which is Afiqah Izzati. Line integral and vector field have many important applications. A line integral is used to calculate the mass of wire, while the vector field can be used to present many physical quantities, gravity and electricity. The first sub-equation is evaluate line integral y cubed minus x squared ds for the following curves. C is the line segment from 2, 4 to 0, 0, followed by the line segment from 0, 0 to 2, negative 4. First up, we need to sketch a graph using a coordinate that is stated in the question, and then label C1 and C2 as is shown in the slide. For the vector function C1, it's equal to 1 minus t times by coordinate 2, 4 plus t times by the coordinate 0, 0, it will get 2 minus 2t, 4 minus 4t. For C2, it will be 1 minus t times 0, 0 plus t times by 2, negative 4. It will get 2t minus 4t. From the vector function, substitute y and x into the equation. After substituting the equation, it will be integrate 4 minus 4t cubed minus 2 minus 2 3 squared. Square root negative 2 squared plus negative 4 squared dt. So we will get 2 square root 5 integrate 6 4 minus 192t plus 192t squared minus 640 cubed minus 4 plus 86 minus 4t squared dt. After we simplify the equation, we will get 2 square root 5 integrate negative 64 t cubed plus 188 t squared minus 184 t plus 60 dt. After that, we substitute t into the equation and we will get 88 square root 5 over 3. So for C2, we substitute x and y with the coordinate that we got from the vector function for C2, which is, it will be integrate 4t cubed minus 2t squared square root 2 squared plus negative 4 squared dt. And then we will get 2 square root 5 integrate 4t cubed minus 2t squared dt. After the equation, will simplify and we will get 2 square root 5 integrate negative 64 t cubed minus 4t squared dt. For the next step, we need to substitute 1 into t and we will get negative 104 square root 5 over 3. So for the last step, we need to sum up C1 and C2. For the equation, it will be 8t8 square root 5 over 3 plus negative 104 square root 5 over 3. It will get negative 11.9257.
Second, evaluate line integral x cubed dy minus y plus 1 dx for each of the following curves. C is the line segment from 1, 7 to negative 2, 4. First, we must sketch the line integral for C1. And then the vector function, we must do terminal minus initial, which is negative 2 minus 1, we get negative 3. 4 minus 7, we get negative 3. For the parametric equation, for both points x and y, the first value is the initial value, which is 1 and 7. And the second value for both parametric equation is the vector function, which is negative 3t for x and negative 3t for y. X prime, we get negative 3, and y prime, we get negative 3. To integrate C1, we get x cubed dy, which is 1 minus 3t cubed, negative 3t dt. And for y plus 1 dx, we get 7 minus 3t plus 1, negative 3 dt. And then we expand this equation and simplify, we get 81t cubed minus 81t squared plus 18t plus 21 dt. Integrate, and then the final answer, we get 93 over 4. The last question, sketch the vector field for fxy equals to negative yi plus 2xj. First, we must tabulate this table. The left-hand side is for the coordinates and the right-hand side for the vector. For the coordinates, choose any random coordinates. For example, 1 for the point 1, 0. We substitute this point to this equation, we get 0, 2. Second point, we substitute to this equation, we get negative 2, 4. And then after we substitute all of these points, we transfer all of this vector to this graph. For example, point 1, 0, we get 0, 2. This is point 1, 0. And then 0, 2, we must go upwards. Point 0, 1 here. We get negative 1, 0. Negative 1, which is to the left. 2, negative 2. 2, negative 2. We have this. And then we get the vector is 2, negative 4, which is go here. And then we transfer all of the vector to this graph, and then we will get this vector field.